This video is intended to show how the Merg CBUS Beginner's Kit number 101 is built. Further videos will cover testing, connecting the modules, and their configuration in slim mode. Kit 101 consists of 3 standard Merg module kits, a small bag of extra components, and a power supply. Members in the UK will also receive a power lead, but members from elsewhere will need to source a local figure-of-8 power lead. First, I will describe my minimal toolkit and the equipment required for building Merg module kits. I will introduce some extra tools later that can assist in making life easier, but they are not essential. I have a pair of fine-nose pliers and a pair of wire cutters. Do not use these for cutting rail or hard wire, or they'll get ruined. Next is a pair of tweezers. These have ceramic tips, which are heat resistant, non-conducting, and cannot be soldered to something by mistake. Normal stainless steel tweezers can be used instead. The scalpel is used for removing components from the mounting card. I'm using a silicone rubber work mat, which is heat resistant. It's not a cutting mat, so keep the scalpel away from it. A self-healing cutting mat is not heat resistant, so keep the soldering iron away from that. An off-cut block of wood can be used in place of either of these types of mat. A temperature-controlled soldering iron is essential for building electronic modules. It should be powerful enough to get back to temperature quickly after every joint, but will not get so hot that it burns off the flux before it has done its job. I like my one because it is easy and quick to change the bits. I have a large bit for making etch kits, where I need to put a lot of heat into the joint quickly before it dissipates around the rest of the etch. I have a very fine pointed bit for use on surface mount electronic components. I have a standard pointed bit, which I use for most things. And I also have a standard chisel bit, and I use either of these last two as the mood takes me. The world appears to be divided between using brass coil or a wet sponge for cleaning the soldering iron tip. My stand has both, and I use them both. Keeping the tip clean and shiny with a fine coating of solder is very important, and I clean the tip after every joint before putting the iron back into its stand. I use tin lead solder with a resin flux core. No other flux is ever needed for electronics. Save it for etch kits or plumbing. Lead-free solder is now standard in commercial electronics and is used by many hobbyists. It needs slightly different temperatures and different techniques to get the best from it. However, after 45 years of using tin lead solder myself, I will not be changing over to it. You can purchase fancy gadgets to hold a PCB while soldering, or you can go down the DIY route, but I find it easy to use a spare finger to anchor the PCB, leaving the thumb and forefinger free to feed in solder. Finally, as for any close-up work, good lighting is required, and unless you have perfect vision, good optics are required for close-up inspection of your work. This could mean a magnifying glass, jeweler's eyepieces, headband magnifiers, or in my case, spectacles that allow me to focus a few inches from my nose. On a safety note, the tin and lead in solder are both poisonous heavy metals, so wash hands thoroughly after soldering. Also, fumes from the flux are not good for you, so make sure you work in a well-ventilated area and try not to breathe in the fumes directly. I use an extractor fan with carbon filters to pull the fumes away from my workbench. As with all Merg kits, we have written instructions with plenty of diagrams and photos to show you how to build the modules. It's really important that you take the time to read them carefully before starting construction. That way you will avoid any unpleasant surprises. The instructions that come with Kit 101 say to start by building the Kanak 8 module. So open up the packet and carefully remove the contents. There is another printed instruction sheet, a bag of bits, a contents list, and finally there is a card with small components taped to it. Wrapped up in the instruction sheet is the printed circuit board, or PCB. The card with the small items taped to it lists the component numbers and the type of the component and the resistance value or capacitance as appropriate. Do not remove the components from the card until you are ready to use each one so that they don't get mixed up. The PCB is clearly marked, showing where each component will be located. The components have identification numbers such as R1, R2, R3, etc. The bag of bits can be emptied into a yogurt pot or something similar to keep them safe, but easy to find and extract. The black foam is a special conductive anti-static foam to protect delicate components. So again, do not remove any components from the foam until you are ready to use them. It is usual to install smaller, more robust components first, leaving larger or more delicate components to a later stage. The instructions that come with Merg kits provide a construction sequence that has been determined to be efficient and simple to follow. The Kit 101 instructions suggest some changes to the normal Kanak 8 instructions, advising replacement of these 3 lines with the following 4 lines of text. To avoid any confusion, I would strike through the indicated 3 lines on the Kanak 8 instructions sheet. Then do the same on the Kit 101 instructions. Now we are ready to start following the 4 lines of text in the Kit 101 instructions. The first instruction is to fit the resistors, identified as R1, R2, R3, up to R10. Resistor values are normally indicated by a series of coloured bands. Each colour represents a number from 0 to 9. Although it's useful to remember all the colour codes, you can get a long way just learning the first few. Black is 0, brown is 1, red is 2, and orange is 3. Most resistors have 3 coloured bands, representing the value in ohms, then a gap, and another ring denoting the tolerance. This used to be gold or silver to denote 5% or 10% tolerance. The first 2 coloured bands are 2 digits. The third band is a multiplier of 10 to the power of the colour value, or more simply, the number of zeros to put after the first 2 digits. So these resistors show brown, black, orange, which is 1, 0, and then 3 more zeros. So 10,000 ohms, or 10K. Newer resistors have a closer tolerance, so red and brown are used to denote 2% or 1% tolerance. With a closer tolerance, 4 colour bands are sometimes used to show the value, 3 digits and a multiplier. So brown, black, black, black represents 1, 0, 0, and 0 following zeros. So 100 ohms. This is the same as brown, black, brown, or 1, 0, and 1 following 0. The card the resistors are mounted on show the colours and the value for you, but it's a good idea to double check before removing the resistor from the card, as mistakes do sometimes happen. If the colours are faded and difficult to make out, you can double check using a multimeter. Remove the first resistor from the card. It is labelled R1, so we need to find where R1 is on the PCB. Laying the resistor in its place, you can see holes for its leads to go through, a couple of millimeters from each end of the component. Using the pliers, hold the lead next to the component and gently bend the lead at right angles. Holding the pliers between the component and the bend means no strain is applied to the joint where the lead enters the resistor. Repeat the process on the other end of the resistor. Choose a top edge of your PCB. The orientation of the labelling usually makes this fairly obvious. Although it does not matter which way round resistors are fitted, it's good practice to fit all the resistors so the colour code can be read either from left to right or from top to bottom. Poke the two leads of the resistor into the holes in the PCB. Press firmly against the PCB and gently splay the leads apart to hold it in place while soldering. Again, it is good practice to make all joints and connections mechanically sound before soldering, rather than relying on the solder to hold things together. Now for what many people seem to think is a mystical dark art, soldering. Many people have trouble with this, either because they're scared of it, or they just don't understand the correct procedures. One mistake I often see is people loading up solder on the end of the iron and then carrying it to the joint. All that lovely flux inside the solder has disappeared long before reaching the PCB. Being scared of overheating things causes some people to just poke away timidly at the joint. All this will do is irritate the component and put it into a bad mood. So, start with a clean, lightly tinned bit. Push it firmly into the joint so that it is touching both the lead and the PCB pad. Then push in plenty of solder so that it runs all round the lead. Remove the solder and then wipe the iron up the lead and away. Clean the bit again and return the iron to its stand. Repeat the process for the other lead. Apply the soldering iron, then add the solder, take away the solder, wipe the iron up the lead and away. Job done. Now closely inspect the joints. They should be like small shiny volcanoes. No holes, no gaps, no blobs, and no mess. When satisfied, cut off the leads just above the solder and drop them into another yogurt pot. We will need a few of these offcuts later on. I will work my way down the card one at a time rather than following numerical order. 9 more resistors to fit, so I'd better get a wiggle on. So remember, clean, lightly tinned iron pressed into contact with both the component lead and the PCB pad. Give it a second to heat everything up and then push in plenty of solder, watching it flowing around the lead. Remove the solder and then wipe the soldering iron up the lead and away. Clean the tip and put it back in its stand. Note that the iron remains still while the solder is being applied. There's no need to move it around, it's not a paintbrush. Now that is all done and the joints have been inspected, we can tick off the line in the Kit 101 instructions. The next line tells us to use some of the offcut component leads from our yogurt pot to form 5 wire links. These are shown on the PCB as white lines between pairs of holes. Bend a lead up to fit the location. Fit the link and gently bend the ends to keep it in position, then solder it in, just like a resistor. Trim off the ends of the leads. When all 5 links have been fitted, we can tick off another line. The next instruction is to fit a diode that is supplied in the bag of extras with Kit 101. The diode has a silver band on one end, which indicates which way round it must be fitted. It must match the diagram and the photo in the Kit 101 instructions. When checking the position on the PCB, you will see that the holes are very close to the ends of the diode. Bending the leads that close could damage the diode, so instead I will introduce pigtail curls. Holding the lead with the pliers just beyond where the hole would be, I bend the lead up and over the pliers and then back down again. I repeat this on the other lead. The leads are now the correct distance apart to fit the holes, but the bends in the leads are nowhere near the diode. The diode leads are fatter than the resistors and are a tight fit in the holes, but they will go in with a push. Solder the diode in and then trim the leads. One of these leads will form another wire link as shown in the instructions. When the link has been fitted, check it against the photo in the instructions and then tick off the line. The next instruction for Kit 101 is to fit the right-angled female connection from the bag of bits in the experimenter's kit. Insert it into the PCB as shown, and then bend the 2 end pins to hold it in place, and then solder all 10 pins. Tick off the paragraph in the instructions. The final instruction here is to replace the electrolytic capacitor supplied with the kanak 8 kit with a tantalum bead one from the bag of extras in the Kit 101 box. I amended the kanak 8 instructions to fit C1 along with the other 3 tantalum bead capacitors, and crossed through the later instruction to fit the electrolytic capacitor C1. The amendment instruction in the Kit 101 build instructions could then be ticked off. This is the last instruction for the kanak 8, so we can start running through the amended kanak 8 build instructions. The first instruction that has not been struck through yet is to fit the push button S1. This is found in the black foam. Push it into its holes so that it lays flat against the PCB and solder it in place. Tick off the instruction. The next job is to fit the dill sockets. These are also on the black foam. Make sure the half moon cutout on one end is fitted to match the outline on the PCB. Note that one of these is mounted the other way round to the other two. Make sure all the pins pass through the PCB, then bend over the legs on 2 opposite corners, just enough to hold in place whilst soldering these 2 legs. Check the socket is still flat against the PCB and then solder all the remaining legs. Take care when fitting the larger ones when lining up all the legs with the holes. Another paragraph ticked. Next up is a trim pot or variable resistor. These come in various shapes and sizes, so there are extra holes in the PCB that allow the different types to be fitted. Tick. Now for the resonator. This can be fitted either way round, but I like to make sure that the printing on the side will not be obscured by nearby components. Tick. 4 tantalum bead capacitors, 3 on the card and 1 from the Kit 101 extra bits bag. Tantalum beads have their value and voltage printed on them, along with a plus sign near one lead. This lead is also longer than the other one. When fitting, make sure this lead aligns with the plus sign printed on the PCB. The holes for C1 are too far apart, so bend the leads neatly with the pliers to get the correct separation. Fit with the longer lead, marked with the plus sign, in the hole nearest the plus sign printed on the PCB. Now fit the other 3 tantalum bead capacitors. Next job is to fit the LEDs. Again, they have to be fitted the right way round, and again they have a longer lead to denote the positive one. This lead has to go in the hole closest to the plus sign marked on the PCB. The yellow LED is labelled LD1 on the PCB. LEDs are more prone to damage by overheating than other components, but by now you should have had enough practice to make good joints relatively quickly. You can blow on the joint to cool it down after each application of the soldering iron. Repeat for the green LED, which is labelled LD2. The set of 6 dual inline switches is another device that can come in a variety of types, but they all fit the same set of holes. Treat it the same way as the integrated circuit sockets earlier. Tack the 2 diagonally opposite pins and check that it is lying flat and square before soldering all the pins properly. A black terminal block is used for the power supply, and green ones for the CBUS connections. The green ones come in pairs and can be slotted together to form longer blocks. In this case, a set of 4 is required. Fit the 4-way block with the holes for the wires by the edge of the PCB. Solder the pins, ensuring the block stays flat against the PCB. There is an extra hole for the power supply terminal block to allow for an alternative type of connector to be used. The large pins of this terminal block may require more heat to enable the solder to flow properly. A 5-way pin header is a standard feature on all Merg CBUS PIC-based modules. To make this from the 6-way header supplied, pull one of the center 2 pins out. It then fits to the PCB and can be soldered in. Check it is sitting flat on the PCB after the first pin has been soldered, before soldering the other 4 pins. This header allows for connection to a PIC programmer to reload the firmware if required. It rarely needs to be used. There are 2 voltage regulators. One is labelled LM317 and is identified on the PCB as U5. The other one is labelled 7805 and is U2 on the PCB. Check carefully you have the one labelled 7805 and insert it into the position marked U2. The metal tab of the regulator should be by the edge of the PCB. Push it down to where the legs get wider. Again, more heat may be required to get the solder to flow, especially for the center pin, which is connected to the heatsink tab, so the soldering iron may need to be applied for longer. Again, double check you have the regulator marked LM317 and fit it to the position labelled U5 on the PCB. The metal tab of the regulator should be by the edge of the PCB. Push it down to where the legs get wider. Solder it to the PCB and trim the legs. That completes the soldering for the kanak 8 module. The last job for now is to fit heatsinks to the 2 voltage regulators. There is a black heatsink, a screw, a nut and a lock washer for each regulator. Put the screw through the heatsink and the tab of the regulator. Put the washer on the screw and fit the nut. Make sure the nut is on tight. Use pliers and a screwdriver. The heatsinks can be fitted with the vanes sticking out from the boards, but I think it is neater to have them pointing inwards. Make sure they cannot touch any other components. The vanes can be gently bent away from danger. It will be easier to test the module when we come to connect everything together later. So for now, pop it back into its bag with the remaining components. Now it is time to start the canak 8C module. The Kit 101 instructions say to build the canak 8C following its supplied instruction sheet. As with the canak 8 kit, the canak 8C kit comprises an instruction sheet, a PCB, a bag of bits and a parts list. It does not have a card with the components taped to it. All the bits are in the bag. The only addition would be the right angle connector from the experimenter's kit bag, as we did with the canak 8 module. Construction starts with 2 wire links and 4 resistors. You will have to check the coloured bands on the resistors to make sure the correct ones are fitted where required. R1 is brown, black, orange, R5 is brown, black, yellow, and R6 and 7 are both the same, brown, grey, red. Fit the wire links and the resistors as you did on the canak 8. Nothing new here. I would fit the right angle socket from the experimenter's kit at this stage. Now we fit some resistor networks, often known as resnets. These are multiple resistors in a single package. R2 and R3 each contain 8 resistors in a single line package, with a common link to one end of all the resistors. The common link pin is indicated with a large dot. The printing on the PCB highlights where this should go by showing a box around the hole. Fit the two resnets R2 and R3. They are identical. Resnet R4 is a set of 8 unconnected resistors in a dual in-line package similar to an integrated circuit. As with integrated circuits, you will see that the legs splay out, which makes them difficult to fit. I like to make them parallel before fitting. This can be done by pushing gently onto a block of wood, both sides, until they are parallel. I found a handy gizmo on eBay that you drop an integrated circuit into and squeeze. All the legs are then nice and parallel. You can now drop the resnet R4 into the holes and solder it in, as you did for the IC sockets on the Kanak 8 module. It does not matter which way round it is fitted. The push button switch and IC sockets are fitted next, making sure the cutout on the ends align with the PCB markings. Then fit the resonator, capacitor, LEDs, 6-way switch and the terminal block J1. If you intend to use the module on a layout later, you can choose to fit the terminal block J2, but it can always be fitted at a later date. The 5-pin in-circuit serial programming connector is formed in the same way as for the Kanak 8 module, removing the unwanted pin. 3 2-pin header connectors are required. These will be used when configuring the module later. That is the Kanak 8C module, built, complete and ready for testing. Put it back in its bag with the remaining items from its bag of bits, and now we can assemble the experimenter's kit modules. The experimenter's kit comprises a set of instructions, a PCB and a bag of bits that we have already delved into. The PCB is actually 3 PCBs joined together. You need to snap them apart. We only need TM1 and TM2 at the moment. TM3 will be needed if you get the supplementary beginner's kit 102. Module TM1 only has a bank of 8 on-off switches and a right-angled header connector. You can optionally fit 8 push-button switches, like the ones on the Kanak 8 and Kanak 8C modules, but these are not supplied. Module TM2 also has a right-angled header connector, but also has a resnet resistor network and 8 red LEDs. You should know how to fit these by now. Make sure the LEDs are fitted the right way round, with the longer lead nearest the resnet. So now all the Kit 101 modules are built and ready to be connected up and tested. This will be covered in the next video.